Students, today we will do second topic of application of derivatives, that is increasing and decreasing functions. Now what are increasing and decreasing functions? A function f is said to be increasing on an interval a to b if x1 is less than x2 in interval a to b, implies that fx1 is less than equal to fx2 for all x1 x2 belongs to interval a to b. Alternately, we can say that if f dash x is greater than equal to 0 for each x in interval a b, then we can say that the function fx is increasing. Now function f is said to be decreasing on interval ab for each x belongs to interval a to b if x1 less than x2 in ab, implies that fx1 is greater than equal to fx2 for all x1 and x2 belongs to ab. Alternately, if f dash x is less than equal to 0 for x in interval a to b, then we can say that the function is increasing function. Now that means we can check the value of fx1 and fx2 if x1 is less than x2 in the interval, or we can either find the value of f dash x, and if the value of f dash x is greater than equal to 0, then the function will be increasing, and if the value of f dash x is less than equal to 0, then the function will be decreasing. Come to the exercise 6.2. In first question, show that the function given by fx equal to 3x plus 17 is strictly increasing on R. That means on real numbers. Now function fx is equal to 3x plus 17 is given to us. Now let x1 and x2 be any two numbers in R. Then x1 will be less than x2. And if x1 is less than x2, then 3x1 will be less than 3x2 on multiplying both sides by 3. Now we have to convert this x1 and x2 in the form of 3x1 plus 17 and 3x1 plus x2 plus 17. Now on adding 17 to both ends, 3x1 plus 17 will be less than 3x2 plus 17. As we know, fx is equal to 3x plus 17. So 3x1 plus 17 will be equal to fx1 and 3x2 plus 17 will be equal to fx2. Now on taking x1 less than x2, we are getting fx1 less than fx2 in R. So we can say that f is strictly increasing on R. Now question number second is same as question number first. Now come to question number third. Here we have to show that the function given by fx equal to sin x is a. strictly increasing in 0 to pi by 2, b. strictly decreasing in pi by 2 to pi, and c. neither increasing nor decreasing in 0 to pi. Now function fx is given to us as sin x. Now f dash x, on differentiating with respect to x, we will get f dash x as cos x. Now first part is we have to check whether the function is increasing or decreasing in interval 0 to pi by 2. Since for each x belongs to 0 to pi by 2, this cos x will be greater than 0. Now in interval 0 to pi by 2, cos x is always positive, so cos x will be equal to greater than 0. So we have now cos x the value of the f dash x, so we have f dash x is greater than 0. Now if f dash x is greater than 0, that means function f is strictly increasing in interval 0 to pi by 2. Now in B part we have to check that the function is increasing or decreasing in interval pi by 2 to pi. Now, since for each x belongs to pi by 2 to pi, cos x, value of cos x will be less than 0. Now, in interval pi by 2 to pi, cos x is always negative, or you can say it's always less than 0. So, we can say that f dash x is less than 0. And if f dash x is less than 0, that means that function f is strictly decreasing on pi by 2 to pi. Now, since function f is strictly increasing in 0 to pi by 2 and strictly decreasing on pi by 2 to pi, so from 0 to pi the function will be neither increasing nor decreasing. In question number 6, we have to find the interval in which the following functions are strictly increasing or decreasing. So I am doing E part of it. Now the function is given to us as x plus 1 whole cube into x minus 3 whole cube. Now fx is given to us. Now f dash x will be x plus 1 cube into d by dx of x minus 3 cube, and that will be 3 into x minus 3 square plus x minus 3 cube into d by dx of x plus 1 square and cube, that will be 3 into x plus 1 square. Now that will be 3 into x plus 1 square into x minus 3 square. On taking 3 into x plus 1 square into x minus 3 square as common, we will get x plus 1 plus x minus 3, and that will be 3 into x plus 1 square into x minus 3 square into 2x minus 2. This will give us 6 into x plus 1 square into x minus 3 square, and from here we have taken 2 as common, and this will be x minus 1. Now after finding the value of f dash x, now our second step is we will take f dash x as 0. This will give us values of x as, from here we will get value of x as minus 1, 3 and 1. Now on taking each factor is equal to 0. Now the points x equal to minus 1, x equal to 1 and x equal to 3 will divide the real line in 4 disjoint intervals from minus infinity to infinity. Now from minus infinity to minus 1, from minus 1 to 1, from 1 to 3 and from 3 to infinity. Now here we are getting the intervals from minus infinity to minus 1, minus 1 to 1, 1 to 3 and 3 to infinity. Now sign of f dash x in these intervals. We will first of all find out the sign of f dash x in these intervals. Now from minus infinity to minus 1, we can take any point. Suppose I am taking minus 2. To minus 2, on putting minus 2 in the value of f dash x, we will get this x plus 1 square as positive, x minus 3 square as positive, because the square of every real number will be positive. Now here we have taken minus 2. So minus 2 minus 1 will be equal to minus 3. That means we are getting it as negative. Now positive into negative will be equal to negative. That means sign of f dash x is negative in interval f dash x. Now similarly, from minus 1 to 1, we will take a point. Suppose between minus 1 and 1, I am taking a real number 0. Now on taking real number 0 here, now first this positive, this will give us positive sign, and this will give us negative sign. That means it will also be negative. Now third, 1 to 3. Now between interval 1 to 3, I am taking 2. Now 2 plus 1 square will be positive, 2 minus 3 square will be also positive. Now 2 minus 1 will be positive. All three signs are positive, so that means in interval 1 to 3 sign of f dash x is positive. Similarly, in interval 3 to infinity, the sign of f dash x will be positive. So we can say here from minus infinity to minus 1, the nature of fx is strictly decreasing, as the sign of f dash x is negative. Now here also it will be strictly decreasing from minus 1 to 1. Now from 1 to 3, the sign of f dash x is positive, so the function is strictly increasing in interval 1 to 3, and similarly from 3 to infinity, sign is positive, so the function is strictly increasing. Thus we can say function f is strictly decreasing on minus infinity to minus 1 and minus 1 to 1, and is strictly increasing on 1 to 3 and 3 to infinity. Question number 7. Show that y equal to log 1 plus x minus 2x upon 2 plus x, where x is greater than 1 minus 1, is an increasing function of x throughout its domain. Now function y equal to log 1 plus x minus 2x upon 2 plus x is given to us. On differentiating with respect to x, dy by dx will be equal to 1 upon 1 plus x minus 2 plus x d by dx of 2x minus 2x d by dx of 2 plus x upon 2 plus x whole square. And on solving this, we will get dy by dx as x square upon 1 plus x into 2 plus x whole square. Now as we know that x is greater than minus 1, so we can say that 1 plus x will be greater than 0. Similarly, x square and 2 plus x whole square will also be greater than 0, as the square of the number is greater or equal to 0. Now this means that x square upon 1 plus x into 2 plus x whole square will be greater than 0, or we can say that dy by dx is greater than 0, as this is the value of dy by dx for x greater than minus 1. Thus the function is increasing throughout its domain, as the derivative of the function is greater than 0. Now in question number 8, find the value of x for which y equal to x into x minus 2 whole square is an increasing function. Now function y is equal to x into x minus 2 whole square. On differentiating both sides with respect to x, dy by dx will be equal to 2 into x minus 2 into d by dx of x into x minus 2. Now d by dx of x minus 2 will be x d by dx of x minus 2 plus x minus 2 d by dx of x. Now, or either we can multiply this x with x minus 2 and it will give us x square minus 2x, and d by dx of x square minus 2x will be 2x minus 2. On taking 2s common, we are getting it as, and from the first factor we can take x as common, that will give us 4x into x minus 2 into x minus 1. Now on taking dy by dx equal to 0, the value of x will be 0, 2 and 1. The points 0, x equal to 0, x equal to 1 and x equal to 2 divides the real number line. Now suppose this is a real number line from minus infinity to infinity. So, and this point 0, 1 and 2 will divide it in 4 disjoint intervals that are minus infinity to 0, 0 to 1, 1 to 2 and 2 to infinity. Now intervals are from minus infinity to 0, and from minus infinity to 0 sine of dy by dx. Now from infinity to 0 we can take any point. Suppose I am taking minus 1, to sine of dy by dx will be negative. Here x minus 2, minus 1 minus 2 will be again negative, and minus 1 will be negative, and negative into negative will be negative. Thus we can say that nature of y in this case from in interval minus infinity to 0 is strictly decreasing as dy by dx is negative. Now in interval 0 to 1, suppose we can take 0.5 to 4x will be positive, 0.5 minus 2 that will be negative, and 0.5 minus 1 will be negative, and negative into negative will be positive. That means from interval 0 to 1 dy by dx is positive, and thus we can say that y is strictly increasing. Similarly in interval 1 to 2 the sign of dy by dx will be negative, and that means it is strictly decreasing. In interval 2 to infinity, again the sign of dy by dx is positive, and so it is strictly increasing. So we can say that y is strictly increasing in interval 0 to 1 and 2 to infinity, and strictly decreasing in interval minus infinity to 0 and 1 to 2. We have to find the point in which y is strictly increasing. Therefore we can say that y is strictly increasing when x is between 0 and 1, and or x is greater than 2. In question number 9, we have to prove that y equal to 4 sin theta upon 2 plus cos theta minus theta is increasing function of theta in 0 to pi by 2. Now y equal to 4 sin theta upon 2 plus cos theta minus theta is the given function. On differentiating with respect to theta, dy by d theta will be, now in this first part we will apply the division rule, and d by d theta, d of theta will be equal to 1. Now on solving this, we are getting dy by d theta as cos theta 4 minus cos theta upon 2 plus cos theta whole square. Now in interval 0 to pi by 2, cos theta will be positive. That means value of cos theta will be greater than 0. Now value of 2 plus cos theta whole square will be always greater than 0, as square of any real number is equal to 0, is greater than 0. Now here 4 minus cos theta will also be greater than 0, as the value of cos theta will in interval 0 to pi by 2 will be between 1 and 0. That means 4 minus cos theta will be greater than 0. Or we can say that cos theta into 4 minus cos theta upon 2 plus cos theta whole square will be greater than 0, and this was the value of dy by d theta. That means dy by d theta is greater than 0 in interval 0 to pi by 2, which means that the function y is strictly increasing on 0 to pi by 2. 12th question. Which of the following functions are strictly decreasing on 0 to pi by 2? Now first function is cos x, second one is cos 2x, third is cos 3x, and fourth one is tan x. So we have to find out that which of these functions is strictly decreasing on 0 to pi by 2. Our first function was cos x. So let f1x is equal to cos x. On differentiating both sides, f1 dash x will be d by dx of cos x, and that will be minus sin x. As sin x is greater than 0 in interval 0 to pi by 2, so minus sin x will be less than 0 in interval 0 to pi by 2, and that means that f1 dash x is less than 0 on 0 to pi by 2. Thus we can say that f1x is strictly decreasing on 0 to pi by 2 as f dash x is less than 0. The second function was cos 2x. Let f2x equal to cos 2x. On differentiating both sides with respect to x, f2 dash x will be equal to minus 2 cos 2 sin 2x. Now as x lies between 0 to pi by 2, so we can say x is greater than 0 and less than pi by 2. Now on multiplying each term by 2, this 2x will lie between 0 to pi. Now in interval 0 to pi, the value of sin is positive. That means sin 2x will be greater than 0. Or we can say minus 2 sin 2x will be less than 0. And that means f2 dash x is less than 0 in interval 0 to pi by 2. Thus we can say that f2x is strictly decreasing in interval 0 to pi by 2. Now the third function was cos 3x. So let f3x equal to cos 3x. On differentiating both sides, f3 dash x will be equal to minus 3 sin 3x. Now on taking f3 dash x equal to 0, we will get minus 3 sin 3x equal to 0, or we can say sin 3x equal to 0. And this will give us 3x equal to pi, as sin pi is equal to 0. So x will be equal to pi by 3 as x belongs to 0 to pi by 2. So we will take the value of x between 0 to pi by 2, and that is pi by 3 here. Now this pi x equal to pi by 3 will divide the interval 0 to pi by 2 in two disjoint intervals, 0 to pi by 3 and pi by 3 to pi by 2. Now in interval 0 to pi by 3, now as we know that x lies between 0 to pi by 3 here, and here we have to find the value of 3x. So 3x will lie between 0 to pi. Now in interval 0 to pi by 3, f3 dash x will be equal to minus 3 sin 3x, and that will be less than 0, as sin 3x will be greater than 0 in interval 0 to pi. So minus 3 sin x will be greater than less than 0 in interval 0 to pi. Thus we can say that f3x is strictly decreasing in interval 0 to pi by 3. Now in interval pi by 3 to pi by 2, x will lie between pi by 3 to pi by 2, and that means 3x will lie between pi to 3 pi by 2. Now f dash 3x, that is minus 3 sin 3x, will be greater than 0, as sin 3x is less than 0 in interval pi to 3 pi by 2, and thus we can say minus 3 sin 3x will be greater than 0 in interval pi to 3 pi by 2. Now that means f3x is strictly increasing in interval pi by 3 to pi by 2, as f dash 3x is greater than 0 in interval pi by 3 to pi by 2. Now here 3x is strictly decreasing in interval 0 to pi by 3 and strictly increasing in interval pi by 3 to pi by 2. So we can say that f3 dash x is neither increasing nor decreasing in interval 0 to pi by 2. Now our fourth function was 10x. So let f4x equal to 10x. On differentiating both sides, f4 dash x will be equal to sec square x. Now in interval 0 to pi by 2, now the sec square x, value of sec square x is greater than 0, as square of any number will be always greater than equal to 0. So we can say that f4 dash x will be greater than 0 in interval 0 to pi by 2, and thus f4 is strictly increasing in interval 0 to pi by 2. Thus, from the above results, we have seen that cos x and cos 2x are strictly decreasing in 0 to pi by 2. Thus, our option A and B are the correct options, or A and B are the answers of the given question. Now in question number 14, find the least value of A such that the function f given by fx equal to x square plus ax plus 1 is strictly increasing in on 1 to 2. Now function fx is given to us. On differentiating with respect to x, f dash x will be equal to 2x plus a. Now function f will be increasing in interval 1 to 2 if this f dash x is greater than 0 in interval 1 to 2. Now on taking f dash x greater than 0, we are getting x greater than minus a by 2. Therefore, we have to find least value of a such that x is greater than minus a by 2, where x belongs to 1 to 2. Thus, the least value of a for f to be increasing on 1 to 2 is given by minus a by 2 is equal to 1. Now we have to find the least value. So here we will take minus a upon 2, or x equal to the initial value of the interval. That means minus a upon 2 equal to 1, and that will give us a equal to minus 2. Thus we can say that the required value of a is minus 2. Now in 15th question, let I be any interval disjoint from minus 1 to 1. This I is disjoint from minus 1 to 1. We have to prove that the function f given by fx equal to x plus 1 upon x is strictly increasing on I. Now fx is equal to x plus 1 upon x. That means f dash x will be equal to 1 minus 1 upon x square, or that will be equal to x square minus 1 upon x square. Now on taking f dash x equal to 0, we are getting the value of x as plus minus 1. This x equal to minus 1 and x equal to plus 1 will divide the disjoint interval from minus 1 to 1 in interval minus 1 infinity to minus 1 and 1 to infinity. Now the interval is disjoint from minus 1 to 1. So the disjoint interval from minus 1 to 1 will be divided by minus 1 and 1 in two disjoint intervals, that is minus infinity to minus 1 and from 1 to infinity. Now in interval minus infinity to minus 1, f dash x will be greater than 0. Now in interval minus infinity to minus 1, now the value of x square will be positive and greater than 1, and minus 1 x, so x square minus 1 will be greater than 0, and that means x square minus 1 upon x square will be greater than 0. So we can say that f is strictly increasing in interval minus infinity to minus 1. Similarly, in interval 1 to infinity, f dash x will be greater than 0, as x square will be greater than 1, and so x square minus 1 will be greater than 0, and thus x square minus 1 upon x square will be greater than 0. So we can say f is steadily increasing in interval 1 to infinity. Thus, f is steadily increasing from minus infinity to minus 1 and from 1 to infinity, means that f is steadily increasing on interval disjoint from minus 1 to 1. Now in 19th question, the interval in which y equal to x square e raised to power minus x is increasing is, we have to obtain the interval. Here we have to find the interval in which y equal to x square e raised to power minus x is increasing. The function given to us is y equal to x square e raised to power minus x. Now on differentiating both sides with respect to x, dy by dx will be equal to x e raised to power minus x into 2 minus x. On taking dy by dx equal to 0, x will be equal to 0 and 2 minus x will be equal to 0, and that will give us x equal to 0 and x equal to 2, which divides the real line into 3 disjoint intervals from minus infinity to 0 and from 0 to 2 and 2 to infinity. Now, in interval minus infinity to 0, sine of dy by dx. Now, in interval minus infinity to 0, now as we know, the exponential function is always positive. So, the sine of dy by dx will depend upon the sine of x and 2 minus x. Now, in interval minus infinity to 0, suppose in interval minus infinity to 0, we can take any number. I am taking minus 1. Now, if we take x as minus 1, its sign will be minus 1 into 2 minus minus 1, and that will be minus. Here, from here we will get the sign of x as negative, and from here we will get the sign as positive. So we can say that negative into positive will give us the negative sign. So from minus infinity to 0, dy by dx is negative, and thus y is strictly decreasing. Now in interval 0 to 2, now x will be positive and this 2 minus x will be also positive, and that means the sign of dy by dx is positive, and thus it is strictly increasing in interval 0 to 2. Now in interval 2 to infinity, the sign of x will be positive and sign of 2 minus x. Now 2 to infinity, if we take 3 in place of x, then 2 minus 3 will be equal to minus 1. That means sign of 2 minus x will be positive, negative, and sign of x was positive in interval 2 to infinity. That means the sign of dy by dx will be positive into negative, and that will be negative. Thus, fx is y is strictly decreasing in interval 2 to infinity. Thus, we can say that f is strictly decreasing on minus infinity to 0 and from 2 to infinity, and is strictly increasing from 0 to 2. Thus, our correct option is option D. That means the function y equal to x square e raised to power minus x is increasing in 0 to 2.